Hello friends, welcome to Engineering Funda family. In this video, I am going to solve 6 very interesting questions based on conductivity and resistivity. Let me show you those questions first, and what I want is you just try out all those questions by your own first. Later you can check for the solution. So this is first question, then you see this is second question. In between you can freeze the video and try this solution by your own, right? This is third question, this is fourth question, this is fifth question, and this is last one, that is sixth question. So I hope you might have freezed the video. Now let us solve first question over here. So in first question, what is given? An n-type silicon bar of length 0.1 centimeter long and 100 micrometer square cross-sectional area has a majority carrier concentration of this and carrier mobility, that is this, at room temperature 300 Kelvin. If the charge of electron is given, then we need to find resistance of bar. So question is there based on resistance, and as per the data which is given to you, you can immediately say what is resistance? Resistance of bar, that is rho L by A, right? From schooling itself you might be knowing this formula. Resistance is resistivity into length divided by cross-sectional area. So here, see L and A that is given to you, resistivity that you need to find. Now what is resistivity? Resistivity, that is 1 by conductivity. Resistivity, that is 1 by conductivity, right? Now what is conductivity? So for that, let me explain you those things separately. See, conductivity, that is N mu N plus P mu P into charge, right? That is what we have derived in my theory video. Now see here, n-type silicon that is given to you. In n-type silicon, this portion P mu P, that will be very small compared to this. So you need to neglect this, right? So you can say this conductivity is N mu N into charge. Now we need to place this over here so that you can have resistivity calculation. So resistivity, that is 1 divided by N mu N into charge into L divided by A. Now here, see all the datas are there with us. Just we need to see how units are there. So we need to convert units as per requirement, right? So if you observe here, mobility that is there in terms of meter square per volt second, and here this cross-sectional area is there in terms of micrometer square, and length is there in terms of 0.1 centimeter. So what I'll do is I'll convert that in terms of meter. So here, see first L that is there in numerator. So 0.1 centimeter means 10 to the power minus 3 meter, right? Now N, so concentration of electron that is given 5 into 10 to the power 20 per meter cube. So 5 into 10 to the power 20 per meter cube. Mu N, mobility, that is given over here, that is 0.13 meter square per volt second. So 0.13, that is mobility. Charge of electron, that is 1.6 into 10 to the power minus 19. Then here area is there. Now you see what is area? 100 micrometer square. So 100 and micrometer square is there, right? So you can say micro means 10 to the power minus 6 and square means 10 to the power minus 12. So this is how you can convert everything in terms of one dimension, and then you will be having resistance, and that resistance will be there in terms of ohm over here, right? So see how to solve this. 10 to the power 20 and 10 to the power 19, so 10 to the power 1 into 10 to the power 2 means 10 to the power 3 into 10 to the power minus 12 means 10 to the power minus 9, and in numerator 10 to the power plus 9 will be there, and 10 to the power plus 9 into 10 to the power 3, that will be 10 to the power 6, right? That will be 10 to the power 6. And if you solve this, 1 divided by 5, 0.13, 1.6, then what will be your answer? You just solve that in your calci. Let me check my answer over here. That is 0.13 9615. That is what I'm getting, right? But if you observe here options, then that is given in terms of 10 to the power 6, 4, like this, right? So nearest one that we need to choose. So I can say nearest one is 10 to the power 6 ohm, right? So your correct option will be this. So that is how you will have to solve the question. So every time you just need to focus about how units are there, and then you need to solve the question, right? Let us have second interesting question now. So in second question, a silicon sample is uniformly doped with donor type impurities with a concentration of 10 to the power 16 per centimeter cube. The electron and hole mobilities in sample are 1200 centimeter square per volt second and 400 centimeter square per volt second respectively. Assume complete ionization of impurities. The charge of an electron that is given. The resistivity of sample is, so we are dealing with to find resistivity. Here we are not calculating resistance. Remember, here we are calculating resistivity. So what is resistivity? Resistivity is rho, and that is 1 by conductivity. And conductivity that we have derived in my theory video, that is n mu n plus p mu p into charge. Now here you see silicon sample that is doped with donor types of impurity, right? So when you doped it with donor types of impurity means that silicon will be n type. So here we are having n type silicon. So in n type silicon you should know, see this proportion of p mu p that will be very lower compared to n mu n. So we need to ignore this proportion, right? So here you will be having this formula in terms of 1 divided by n mu n into charge. Why? The reason is we are talking about n type semiconductor material, right? Now whatever data that we have, that we need to place it over here. So 1 divided by n. Now electron concentration, that is 10 to the power 16. Then mu n. So electron and hole mobilities are there. So electron mobility is 1200, and you see charge that we need to have. So 1.6 into 10 to the power minus 19. So now you will be having, you see this 10 to the power 16 and 10 to the power minus 19, that will make it to 10 to the power minus 3 in denominator. So in numerator that will be 1000, and 1000 divided by 1200 into 1.6. This is what you'll have to solve. Let me check my answer over here. So my answer is 0.52 ohm into centimeter, right? Resistivity will be there in terms of ohm into centimeter with these units. You see everything is there in terms of centimeter. So resistivity will be ohm into centimeter. So this will be our correct answer over here. Let us move on to third interesting question now. So in third question, the resistivity of a uniformly doped n-type silicon sample is 0.5 ohm centimeter. So here we are given with resistivity. If the electron mobility, that is 1250 in terms of centimeter square per volt second, the charge of electron that is given, the donor impurity concentration is how much? That is the question. So here we are given with n-type silicon, right? And resistivity is given. So what is resistivity? In my last example also I have explained resistivity is 1 by conductivity, and conductivity equation is n mu n plus p mu p into charge. And here we are talking about n-type silicon. So for n-type silicon you should know proportion of p mu p, that is negligible compared to this. So your equation will be 1 divided by n mu n into charge. And here we are dealing with to find donor concentration. So you should know in n-type material, this small n, that is donor concentration Nd, right? So from this you will have to find Nd. So you can say Nd will be 1 divided by rho mu n into charge. Now all the data that we have, so rho is how much? 0.5. Then electron mobility is how much? 1250 and charge is 1.6 into 10 to the power minus 19 coulomb, right? And if you observe here units, so units are there in terms of centimeter, right? So your answer will come in terms of per centimeter cube over here. You don't need to go for conversion every time. So if you solve this, then you see what will happen. This 10 to the power minus 19 will go in numerator and you will have to solve this in calculator. So your answer will be 10 to the power 16 per centimeter cube. So your correct option, that will be this, right? I hope you are solving that in Calci. Right now it is a bit difficult for me to solve it by calculator, as in computer system I don't have that calculator over here with my tablet, right? So let us move on to next interesting question now. So in fourth question, a heavily doped n-type semiconductor has the following data, where electron mobility ratio, whole electron mobility ratio, that is given. Whole electron mobility ratio means mu p by mu n, that is 0.4, that is given to us. Doping concentration, that is also given. Doping concentration of n-type, that is given, right? Intrinsic concentration is also given. The ratio of conductance of n-type semiconductor material to that of intrinsic semiconductor material of same material and at the same temperature will be how much. So we are dealing to find ratio of conductance. Now let me write that first. Ratio of conductance for n-type to ratio of conductance for intrinsic, right? So IN, that I am writing. You should know, see, with same dimensions, conductance ratio will be conductivity ratio, right? So here you can say sigma n divided by sigma in, right? See, that is how ratio will come, as if dimensions are same. Now here, see, conductivity, that we know, right? What is conductivity? That is Q into n mu n plus p mu p. And here for intrinsic, that will be Q into n will be ni mu n and p will be also ni. Why? The reason is, in intrinsic semiconductor material, value of n and p will be same. So here, see, for Qn means for n-type semiconductor, value of p mu p, that will be relatively very smaller compared to this, so we need to neglect this. And from denominator we can take ni common, right? So this q will get cancelled, and in numerator you will be having n mu n divided by ni common and mu n plus mu p, right? Now here what is given, you see, mu p by mu n, that is given, and n and ni is also given, right? So here what we can do is, we can say this conductance ratio for n-type and intrinsic, that will be, now you see, in numerator there will be n and divided by ni, and I am dividing this mu n in denominator as well. So I'll be having 1 plus mu p by mu n, and we are having all the data. So just substitute that. N is how much? Doping concentration. So that is 4.2 into 10 to the power 8 divided by ni, that is 1.5 into 10 to the power 4, and 1 plus mu p by mu n. Mu p by mu n is 0.4. So 1 plus 0.4, that is 1.4, right? So just substitute that over here. So if you solve this, 10 to the power 8 divided by 10 to the power 4, so that will make it to 10 to the power 4, and 4.2 divided by 1.5 and 1.4, so that has to be 2 only. So you can say this is 20,000, right? This ratio will be 20,000. So this option is correct. So that is how simply we can solve these questions. Let us move on to fifth question now. This fifth question, that is based on graph. So few basic things that you need to know over here. Let me read the question first. A piece of silicon is doped uniformly with phosphorus So when you dope things with phosphorus, you will be making N-type semiconductor material, right? With a doping concentration of 10 to the power 16 per centimeter cube. So here doping concentration is given. The expected value of mobility versus doping concentration for silicon assuming full dopant ionization is shown below. So here we are given with graph in which mobility versus doping concentration graph that is given to us. The charge of electron is given, as well as we need to find conductivity of silicon sample at 300 Kelvin. So we need to find conductivity. Let me show you how to have conductivity. You should know basic formula of conductivity, right? Conductivity, that is N mu N plus P mu P into charge. And we are talking about doping with phosphorus, means we will be making N-type semiconductor material. And you should know with N-type semiconductor material, value of P mu P, that will be very smaller compared to this. So you'll have to ignore this term. So you can say conductivity is N mu N into charge. Now you see how many things that is given to us. Doping concentration, that is given N. Q is also given, that is charge. But mu N, that we need to find from this graph. Now here you see doping concentration, that is 10 to the power 16, that is this line, right? That is this line. And at this mobility that we can have. So if you move on to this direction, at this point mobility is 1200. So we need to place 1200, which is mu N over here. So from graph we need to substitute value, otherwise things are very simple, right? So here this N is 10 to the power 16, then mu N, that is 1200, and then Q, that is 1.6 into 10 to the power minus 19. So here 10 to the power minus 19 into 10 to the power 16, that will make it to 10 to the power minus 3 into 1200 into 1.6. So if you solve this, my answer is 1920, right? And again, if you multiply this over here, then you will be getting 1.920, right? That is conductivity in this unit only. You should know conductivity, that is mho per centimeter, and we can write that as per S centimeter inverse E1, right? So you can say this is S per centimeter E1. Mho per centimeter means some books are using this notation as per centimeter as well, right? So that is how simply we can solve the question. Now let us move on to last interesting question. Last question is quite interesting. Let us read it first. See, in last question, a silicon sample A is doped with 10 to the power 18 atoms per centimeter cube of boron. So here we are having sample A, and sample A is doped with boron. Boron means this is P-type material. So here you can say this is P-type material in which doping concentration is 10 to the power 18 atoms per centimeter cube, that is given to us, right? Another sample B of identical dimension is doped with 10 to the power 18 atoms per centimeter cube of phosphorus. So here second material is there, that is doped with phosphorus, means that will be N-type material, and that is doped with 10 to the power 18 atoms per centimeter cube. With that concentration we are doping this. The ratio of electron hole mobility is 3. So here mu N by mu P, that is 3, that is given to us. The ratio of conductivity of sample A to B is how much? So we need to find ratio of conductivity of A to B. So what is the question you see? Question is conductivity of A divided by conductivity of B. What is conductivity? Conductivity is N mu N plus P mu P into charge. For A and for B, formula is same, right? There is no difference. But here we need to see what is A and what is B. If you observe here, A is P-type. So in that you will have to ignore N mu N. Why? The reason is that is quite small. And B is n type. So in n type, p mu p, that will be quite small, so you'll have to ignore this. So here what will happen? Here you will be having this q will get cancelled, and in numerator you will be having p mu p, in denominator you will be having n mu n. See, concentration of p and concentration of n both are equal, right? So you can even cancel this out. Why? The reason is, see, 10 to the power 18, that is the concentration of p, and concentration of n, that is 10 to the power 18. So we can cancel it. And here what is given to us? You see, we have been given with mu n by mu p, that is 3. And here we are having mu p by mu n. So you can say your answer is 1 by 3, right? Mu n by mu p, that is 3. So mu p by mu n will be 1 by 3. So this option is correct one. So that is how simply we can solve the question. But first you need to understand what is the question. What I have seen is students are thinking like they will have to remember the formula. But you should be practicing in a right way. Then you will be finding these questions are very easy. I hope you are getting all those questions. Still, if anything that you would like to share, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.